Hi friend, how are you? This is last part, okay? Multiple 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 integral INTEGRALS part 8 last part, okay? So in this time I talk about some very most important question answer, okay? Mathematics. So this question is one. This question is triple integration, okay? X plus y plus z, okay, plus 1 to the power square dx dy and dz. How to prove 31 by 60? Okay, so this question is very most important, so please you note down. First you try. Next I solve this question. Okay, so next, we know that, okay, triple integration is equal to x plus y plus z to the power square, okay, plus 1 to the square and dx dy and dz. Next, and is equal to x equal to 0 and y is equal to 0 and z is equal to 0. So x plus y plus z is equal to 1. Next, left hand side integration of 0 to 1 and 0 to 1 minus x and 0 to 1 minus x minus y, okay, into x plus y plus z plus 1 to the power square into dz dy and dx. So is equal to, this value it is 1 by 3 into 0 to 1, okay, 1 by 3 into 0 to 1 and 0 to 1 minus x, okay, and this value it is x plus y plus z plus 1, okay, to the power square into 0 to 1 minus x minus y into dy and dx is equal to 1 by 3, okay, 1 by 3 to 0 to 1, okay, and 0 to 1 minus x, and this value it is 8 minus x plus y plus 1 to the power cube into dy and dx is equal to 1 by 3 into 0 to 1 into dy minus x plus y plus 1 to the power 4 by 4, and this value is 0 to 1 minus x into dx is equal to 1 by 3 0 to 1, okay, 4 minus 8x plus 1 by 4 into x plus 1 to the power 4 into dx is equal to 1 by 3 into 4x minus 4x square plus x plus 1 to the power 5 by 20, and this value 0 to 1, okay, and is equal to 1 by 3 into 2 to the power 5 by 20 minus 1 by 20, okay, and this value it is 31 by 60 proved, okay, because 1 by 3 is equal to 20 and 25 minus 1 is equal to 1 by 3 into 24 by 20, okay, it is 24 by 20, so 60 by 20, oh sorry, 2 to the power 5, sorry, 2 to the power 5 means, okay, 2 into 2 into 2 into 2 into 2, 3 into 5, 8, 16, 32, sorry, 32 minus 1, 32 minus 1, okay, so this value it is 31 by 60. This is proved. Okay, next question, question number 2. Okay, next question. Triple integration. Prove that triple integration x square plus y square plus z square into dx dy and dz is equal to pi by 5 into 5, and where integration where the integration is taken throughout, THROUGH, taken throughout the region, taken throughout the region. Okay, x, y, and z belongs to R3. Okay, and x square plus y square plus z square is equal to less than equals to 1. Less than equals to 1. How to solve this problem? So first you try, next I solve this problem. Okay, this question is very most important question. Okay, please you note down this question answer. So applying transformation. Okay, so x is equal to r sine theta and sine theta cos phi, and y is equal to r sine theta, okay, into sine phi, and z is equal to r cos theta. Okay, so the reasons of the integration transformations to 0 less than r less than equals to 1, and 0 less than equals to theta less than equals to pi, and 0 less than equals to phi and less than equals to 2 pi. Okay, this reason, put it this value, lower limit and upper limit, 0 to 1 and 0 to pi and 0 to 2 pi, and this value r square j Jacobian dr d theta and d phi. So j means d x y and z by d r theta and phi, and is equal to r square sine theta greater than 0, and except r is equal to 0 and theta is equal to 0 to pi, 0 comma pi. Okay, and next is equal to limit epsilon 1 tends to 0 positive, and and sorry, it is, and next is equal to 0 to 1, 0 to pi and 0 to 2 pi. It is r to the power 4 into sine theta dr d theta and d phi. So next, limit epsilon 1 tends to 0 positive, limit epsilon 2 tends to 0 positive, and limit epsilon 3 tends to 0 positive. Integration epsilon 1 to 1 r to the power 4 dr and epsilon 2, okay, pi minus epsilon 3 sine theta d theta, and 0 to 2 pi into d phi. So is equal to 2 pi into limit epsilon 1 tends to 0 positive, limit epsilon 2 tends to 0 positive, and limit epsilon 3 to 0 positive into 1 by 5 into 1 minus epsilon 1 to the power 5 into cos epsilon 2 minus cos pi minus epsilon 2. Okay, and is equal to this value 2 pi into 1 by 5, okay, into 2. So this value it is 4 by 5 pi. This is proved. Okay, next question. Question number 3. Okay, so this question is triple integration z square. Okay, triple integration z square dx, dy and dz is equal to 2 by 15 pi a to the power 5. And when the integration is taken through, when the integration is taken through taken through taken throughout the region Okay, this is x, y and z belongs to r to the power 5, and x square plus y square plus z square less than equals to a square, and z greater than equals to 0. How to solve this problem? Okay, so this given question, it is triple integration. Okay, and this boundary x square plus y square plus z square less than a square means 1. Okay, x square plus y square plus z square less than equals to 1, and this is value. Okay, mm, it is 2 by 15. No, sorry, less than equals to a square, and this value, it is z square into dx dy and dz. Okay, over the upper half of x square plus y square plus z square less than equals to a square. Okay, and is equal to 1 by 2 into triple integration x square plus y square plus z square less than equals to a square, and z square into dx dy and dz, applying the transformations x equal to r sin theta cos phi, and y is equal to r sin theta and sin phi, and z is equal to r cos theta. So show the regions of the integrations transformation to 0 less than equals to r less than equals to a, and 0 less than equals to theta less than equals to pi, and next 0 less than equals to phi less than equals to 2 pi. The Jacobins of transformation is the Jacobins of transformations. The Jacobins of transformation is, so j is equal to dx, y and z by dr theta and phi is equal to r square sin theta greater than 0. So except when r is equal to 0, and theta is equal to 0 to pi. Okay, and therefore required integral okay is equal to okay, and is equal to 1 by 2, it is 0 to okay, and equals to half of 0 to a. This first, it is lower limit is upper limit, lower limit upper limit, lower limit upper limit. So put it this value and this value. So 0 to a and 0 to pi, okay, and 0 to 2 pi. So r square cos square theta into r square sin theta into dr d theta and d phi, and is equal to 1 by 2 into limit epsilon 1 tends to 0 positive, and limit epsilon 2 tends to 0 positive, and limit epsilon 3 to 0 positive. Okay, and this value is epsilon 1 to a r to the power 4, and epsilon 2 to pi minus pi 3 epsilon 3 cos square theta into sin theta into d theta, and 0 to 2 pi into d phi. So is equal to pi into limit epsilon to 0 positive and limit epsilon 2 to 0 positive and limit epsilon 3 to 0 positive. So 1 by 5 into r to the power 5 epsilon 1 to a, and 1 by 3 into cos cube theta, okay, pi minus epsilon 3 to epsilon 2. In lower limit, this is upper limit, so put is this limit value. Okay, and is equal to calculate this side, pi by 15 into 2 a to the power 5 is equal to 2 by 15 a to pi into a to the power 5. This is proved. Okay, so this question is very most important. Okay, so first you find Jacobian transformation and put it this value lower limit, upper limit, and calculate this topic. So this is answer. Next, okay. Next, next question. Question number 4. Okay, question number 4. This question is triple integration Lx plus My plus Nz to the power square to dx, dy, and dz is equal to 4 by 15 pi into L square plus M square plus N square, and taken throughout, okay, the interior of the sphere interior of the sphere x square plus y square plus z square is equal to 1. How to solve this problem? Okay, so this question is very most important. Okay, uh, triple integration this given question x square plus y square plus z square is equal to less than equals to 1. Okay, less than equals to 1, and this value it is Lx plus My plus Nz to the power x square into dx, dy, and dz. Okay, so put it this limit value 0 to 1, 0 to pi, and 0 to 2 pi, same to same previous question. Okay, so Lr sine theta sine phi plus Mr sine theta cos phi and plus Nr cos theta to the power square into sine square into sine theta dr d theta and d phi. Okay, so because x equal to r sine theta cos phi and y is equal to r sine theta sine phi and z is equal to r cos theta. So put it this value. Next, sine theta sine phi. And next is equal to 0 to 1, 0 to pi, and 0 to 2 pi. Okay, and next it is L square r to the power 4 into sine square sine cube theta into sine square phi plus M square r to the power 4 sine cube theta into cos square phi plus N square r to the power 4 sine theta into cos square theta plus 2L M r to the power 4 sine cube theta into sine phi into cos phi plus 2mn r to the power 4 sine square theta into cos theta into cos phi. Okay, plus 2 in plus 2 in r to the power 4 sine square theta into cos theta into sine phi, okay, into dr d theta and d phi. So is equal to calculate this value. It is L square by 5 into 0 to pi into sine cube theta into d theta, and next 0 to 2 pi sine square phi and d phi plus M square by 5 0 to pi sine cube theta into d theta, and next 0 to 2 pi cos square phi into d phi plus n square by 5, okay, n square by 5 0 to pi cos square theta into sine theta into d theta into 0 to 2 pi into d phi. Okay, and all the others integral vanish as 0 to 2 pi 0 to 2 pi cos phi d phi is equal to 0, and 0 to 2 pi sin phi into d phi is equal to 0. Okay, and is equal to L square by 40 0 to pi into 3 sin theta minus sin 3 theta into d theta, and next 0 to 2 pi 1 minus cos phi 1 minus cos 2 phi into d phi plus m square by 40. Okay, 0 to pi 3 sin theta 3 sin theta minus sin 3 theta into d theta into 0 to 2 pi 1 plus cos 2 phi 1 plus cos 2 phi. Okay, 1 plus cos 2 phi. Next 1 plus cos 2 phi into d phi plus 2n square pi by 5 into 1 by 3 into cos cube theta 0 to pi. Okay, and is equal to L square by 40. Okay, into 6 plus 1 by 3 6 plus 1 by 3 cos cos 3 theta, oh sorry, cos 3 phi. Okay, 6 into 6 plus 1 by 3 into cos 3 pi minus 1 into 2 pi plus m square by 40, 6 plus 1 by 3 6 plus 1 by 3. Okay, 6 plus 1 by 3 into cos 3 pi minus 1. Okay, into 2 pi and plus 4 by 15 pi n square and is equal to L square pi by 20 L square pi by 20 into 60 by 3 plus m square pi by 20 into 60 by 3 plus 4 by 50 pi n square is equal to 4 by 15 into L square plus m square plus n square into pi. Okay, this is proved. Okay, next question. Next question number 5. Question number 5. This question is triple integration dx, dy and dz by x square plus y square plus z square. Okay, z minus 2 to the power square. Okay, how to solve this problem? Okay, and is equal to pi into 2 minus 3 by 2 in 3 and extended over the interior of the sphere x square plus y square plus z square is equal to 1. How to solve this problem? Answer. Okay, so this given question. Okay, this region is x square plus y square plus z square less than equals to 1, and dx, dy and dz by x square plus y square plus z minus 2 to the power square. Okay, you use the transformation same to same problem, x equal to r sin theta and cos phi. Okay, this previous it is x equal to r sin theta and cos phi. Okay, and this value x equal to r sin theta and cos phi, and y is equal to r sin theta and sin phi, and z is equal to r cos theta. Put it this value, the transformations of region is 0 less than r less than equals to 1, and 0 less than equals to theta less than equals to pi, and 0 less than equals to phi less than equals to 2 pi. Okay, to put it this value. Next, Jacobian j d x y and z by d r theta and phi is equal to r square sin theta greater than 0, and r is equal to 0 and theta is equal to 0 to pi, and i is equal to I is equal to 0 to 1, 0 to pi, and 0 to 2 pi, and r square sin theta dr d theta and d phi by r square minus 4r cos theta plus 4, and is equal to 0 to 1 r dr and 0 to pi r sin theta d theta by r square minus 4r cos theta plus 4, and 0 to 2 pi. Okay, and into d phi is equal to 2 pi by 4, and this value 0 to 1 r into in r square minus 4r into cos theta plus 4. Okay, and 0 to pi into dr, and is equal to pi by 2. Okay, 0 to 1 r in r plus 2 to the power square minus in r minus 2 to the power square into dr, and is equal to pi 0 to 1 r in plus, okay, in r plus 2, okay, minus in r minus 2 into dr, and is equal to pi 0 to 1 r in r plus 2 into dr minus pi 0 to 1 r in 2 minus r, okay, into dr as r less than equals to 1, and is equal to pi into r square by 2 in r plus 2. Okay, 0 to 1 minus 1 by 2, 0 to 1 r square, 0 to 1 into r square dr by r plus 2 minus r square by 2 in r minus 2. Okay, 0 to 1, and minus 1 by 2, 0 to 1 r square by 2 minus r into dr. Okay, is equal to pi into 1 by 2 in 3 minus 0 to 1 to r square by 4 minus r square into dr, and is equal to pi by 2 in 3 plus 2 pi 0 to 1 1 minus 4 by 4 minus r square into dr is equal to pi by 2 in 3 plus 2 pi. Okay, and 1 minus 4 by 4 in 2 plus r by 2 minus r 0 to 1, and is equal to pi by 2 in 3 plus 2 pi minus 2 pi in 3, and is equal to pi by 2 in 3 plus 2 pi minus 2 pi in 3. Okay, pi common, 2 minus 3 by 2 in 3. Okay, this is proved. Okay, so this question is very most and very important question. Okay, next question, question number 5. Okay, and apply these transformations. Okay, and transformation region 0 to 1 and 0 to pi and 0 to 2 pi and Jacobian. Okay, explain this formula and put it this value and integrate this value, and this is final answer. Okay, this is only calculation part. Next I talk about question number 6. Okay, question number 6. Uh, this question is shows that if R be the shows that if R be the in the interior of the ellipsoid. Okay, ellipsoid x square by a square plus y square by b square plus z square by c square is equal to 1. Okay, and first question, this question is triple integration R. Okay, this question is a square b square c square minus b square c square and x square minus c square a square y square. Okay, minus a square b square and z square and dx dy and dz is equal to 1 by 4 pi square a square b square and c square. How to solve this problem? This is first question. Next, second question, triple integration R x y z dx dy and dz is equal to 1 by 6 into a square b square c square. How to solve this two question? Okay, so please you note down. I provide full details, and this question is very most important. So first question answer, applying transformations and Jacobian transformations. Okay, so first given question, it is question number 1. This question is triple integration root over a square b square c square minus b square c square x square minus c square a square y square minus a square b square and d square and dx dy and dz. Okay, and is equal to 1 by 4 pi square a square b square and c square. How to prove this problem? Okay, the applying transformations, app apply the transformations, x equal to ar sin theta. Okay, x equal to ar sin theta cos phi, and y is equal to br sin theta and sin phi, and z is equal to cr cos theta. Okay, the transform region is given by 0 less than equals to r less than equals to 1, and next 0 less than equals to theta less than equals to pi, and 0 less than equals to 1 minute. Okay, and next 0 less than equals to phi and less than equals to 2 pi. Okay, how to solve this question answer? Okay, so first Jacobins of transformation. Okay, Jacobins of transformation. Okay, so j is equal to a b c r square into sin theta greater than 0, and except r is equal to 0 and theta is equal to 0 pi. Okay, and therefore triple integration therefore triple integration x square by a square plus y square by b square plus z square by c square, okay, less than equals to 1, and this value it is a square b square c square minus b square c square x square minus c square a square y square minus a square b square and z square and dx dy and dz, okay, and is equal to a b c into this value 0 to 1, 0 to 1, okay, this boundary 0 to 1, 0 to pi and 0 to 2 pi. So this value it is 0 to 1, 0 to pi and 0 to 2 pi, and this is root over 1 minus r square Jacobian dr d theta and d phi is equal to a b c 0 to 1, 0 to pi and 0 to 2 pi and root over 1 minus r square j dr d theta and d phi, okay, and is equal to a b c 0 to 1, 0 to pi and 0 to 2 pi root over 1 minus r square into a b c r square, put it this value, and sine theta dr d theta and d phi is equal to a square b square c square into 0 to 1 into r square 1 minus r square into dr 0 to pi, okay, 0 to pi sine theta into d theta and 0 to 2 pi into d phi and is equal to 4 pi a square b square and c square 0 to 1, okay, into r square root over 1 minus r square into dr, okay, because let r is equal to sine u, okay, and therefore dr is equal to cos u du, cos u du, okay, and this value r and u, r value 0, u value 0, r value 1 and u value pi by 2, okay, and next therefore I is equal to 4 pi a square b square and c square 0 to pi by 2 into sine square u into cos square u into du and is equal to a square, okay, a square b square and c square into pi by 2, 0 to pi by 2, 2 into sine square into 2u into du and is equal to pi by 2 into a square b square and c square 0 to pi by 2 into 1 minus cos 4u into du is equal to pi by 4 a square b square and c square. This is proved, okay. So this question is very and very easy question, only you apply Jacobian transformations and x equal to ar sin theta cos phi, y is equal to br sin theta sin phi and z is equal to cr cos theta, okay, I put it this value, integrate this value and this is answer. Next next question, next question, question number 2, okay, this question is triple integration r x y z a dx dy and dz is equal to 1 by 6 x a square b square and c square. How to prove this problem? So this given question, okay, this given question, 1 minute, okay, this given question, integration of triple integration of r x y and z into dx dy and dz is equal to 1 by 6 a square b square and c square, okay, and so this value it is same to same problem, okay, is equal to x square by a square plus y square by b square plus z square by c square less than equals to 1. X, y, z, dx, dy and dz. Okay. And next is equal to 8 into triple integration x greater than 0, y greater than 0 and z greater than 0, and x square by a square plus y square by b square plus z square by c square is equal to less than equals to 1, and x, y, x, y, z and dx, dy and dz is equal to 8 into 0 to 1, 0 to pi by 2. Okay. And 0 to pi by 2 ar sine theta into cos phi br. Okay. And sine theta, sine phi and cr into cos theta into a b c r square into sine theta dr d theta and d phi. Okay. So previous these transformations, because x equal to ar sine theta cos phi and y is equal to br sine theta sine phi and z is equal to cr cos theta. Okay. So is equal to 8 a square b square c square into 0 to 1 r to the power 5 into dr into 0 to pi by 2 sine cube theta into cos theta into d theta and 0 to pi by 2 cos phi sine phi and d phi. Okay. And is equal to 8 into 1 by 6 into a square b square c square into 1 by 4 into sine to the power 4 theta into 0 to pi by 2 into 1 by 2. Okay. Into sine square phi 0 to pi by 2 is equal to 8 into 1 by 6 into a square b square c square into 1 by 4. Okay. Into 1 by 2 and is equal to 2 to 8 and 4 and 2, it is this value, it is 4 cancel, and next this value it is 1 by 6. Okay. 1 by 6 into a square b square c square, 1 by 6 into a square b square c square. This is proved. This is proved. Okay. So this question, this two question is very most important. Next, last final question. Okay. Question number 7. Okay. Last and final question number 7. Okay. Question number 7, this last question. If I is equal to 0 to a e to the power minus x square into dx and proved by expressing I square as a double integral that, okay, pi by 4 into 1 minus e to the power minus a square less than I square and less than pi by 4 into 1 minus e to the power minus 2a square. Okay. And double less than I square. Okay. Prove that express I square as a double integral with pi by 4 into 1 minus e to the power minus a square less than I square less than pi by 4 1 minus to the power minus 2a square, and and deduce that 0 to infinite e to the power minus x square into dx is equal to 1 by 2 root over pi. Okay, how to solve this problem? So next you find this answer. This given question 0 to a e to the power minus x square into dx and 0 to a e to the power minus y square into dy. Okay, and this graph, this is a comma 0 and this value it is 0 comma a. This is, and this point is r comma theta, and this is a comma a point, pi by 4 and this distance r and angle theta, and this point is 0 and a by r is equal to cos theta, and r is equal to a by cos theta is equal to a sec theta. Okay, a sec theta, so is equal to 0 to a and 0 to a e to the power minus x square plus y square into dx into dy, and let x equal to r cos theta and y is equal to r sin theta. Therefore I square is equal to u, and therefore 2r dr is equal to du, and therefore I square is equal to 0 to pi by 4. Okay, I is equal to 0 to pi by 4 and 0 to a square sec theta into e to the power minus u du and d theta, and therefore I greater than 0 to pi by 4 and 0 to a square e to the power minus u du and d theta, and is equal to pi by 4 e to the power minus u into a square to 0. Okay, and is equal to pi by 4 into 1 minus e to the power minus a square. Okay, and I square less than equals to 0 to pi by 4 and 0 to 2a square e to the power minus u du is equal to pi by 4 e to the power minus u and 2, this is limit 2a square, 2a square, okay, to 0, and it is pi by 4, okay, into 1 minus e to the minus 2a square, and next therefore pi by 4 1 minus e to the power minus a square, okay, 1 minus e to the power minus a square and less than I square less than pi by 4 into 1 minus e to the power minus 2a square. Okay, and talking a tends to infinite, and pi by 4 less than equals to I square less than equals to pi by 4, and therefore I square is equal to pi by 4, and therefore I is equal to root over pi by 2. I is equal to root over pi by 2. Okay, this is answer. Okay, so next 0 to infinite e to the power minus x square dx is equal to 1 by 2 root over pi. This is answer. So thank you, take care, goodbye. If you not understand any problem, any question answer, so please you ask me, and thank you, take care, goodbye. This is all, total eight part. Okay, in this chapter multiple integrals. So all question answer very most important. If you not understand any problem, any topic, any question answer, multiple integrals, okay. So please you comment me, and thank you. Take care and goodbye.